Hi, and welcome to my first YouTube video. Who would have thought that? Let me introduce myself for a little bit quickly. My name is André Kamman. I'm a Dutchie. I'm SQL Server geek since 1989, so in IT already for 31 years. And I'm a Microsoft data platform MVP since 2009. I'm a data engineer. I like Azure. I've tinkered with AWS a bit, but don't know much about it. I absolutely love Powershell, and I'm a Python student. And this first video is about my journey as a Python student. My first video is going to be a Python primer for DBAs, as you will. I've been a DBA for many SQL Server instances. I'm more on the data warehousing side now of things now, the modern data warehouse, if you will, on Azure. So I wanted to learn Python, and since I'm used to using PowerShell as my main hammer to do things, I thought I'd do something useful with Python to build out a Python library or script, simple script. Let's start with a simple script, shall we? That does something that PowerShell wouldn't do that well. And I think I found something. I found something that I think Python does way better than PowerShell. But let's see. This is not about how you install a Python and everything. There's way too many videos about that. I'm using VS Code. I've got the Python extension installed, and I'm going to go from there. Also, you need to start with installing some libraries. We're going to use a few. Also a few that are already built in, but there's a few that you need to install with the pip command. What we're mainly going to be using is PyODBC, argparse, and logging, because we're going to build a command that exports tables from SQL Server way faster than you could ever do with Python. Enough slides, right? Let's dive into the code. Let me show you that. What you see here is the, well, not a lot of code. I've started a new GitHub library that has nothing in it besides a title, and it's ready for receiving some Python files because I've told it it's a Python library. So it has the git ignore for Python. There's a license. The license is pretty simple. It's an MIT license. That means do whatever you want with it. If you find this and you find it useful, that's all. Now to start, really simple. We're going to create a new file, and we're going to call the new file bcp.py. BCP, for the old timers, is the bulk copy program in SQL Server, meant to quickly export and import files at blazing speed. The simplest way to export something. It's gotten a bit old and it doesn't really support all the features that I wanted it to support. So what you're stuck with sometimes is the backpack or the import-export wizard or SSIS, if you understand how SSIS works. And it's pretty fast. SSIS is pretty cool, but I wanted something simpler that more people can use, because not everybody understands SSIS, is my experience. What I wanted to do is create a Python-based bulk copy program, but for now we're only going to do some simple things and export only, just to learn how this works. It's my journey through Python as well. We are going to use a datetime library because I want to log how long we're running. And I want to parse some arguments on the command line. I want to give it which database, etc. I want to talk to a SQL server. That's why we need the PyODBC library, and the export format will be CSV, hence the importing of the CSV library. So far, so good, right? Now let's do this parsing. I'll paste that in. It's quite powerful, actually. I like it. There's way more things that I want to do with it, but let's start with these already. All you need is an argument parser, and you add arguments to them. And these four are the mandatory arguments. I need the name of the SQL Server, name of the database, the name of the table that we're going to export, and the location of the output file. And the output file's name will be the table name.csv. That's how we're going to do it for now. And then after that, I have some non-mandatory arguments that you see here. There is a quiet argument if I don't want all the logging in my screen. You call it by saying -- quiet, but there's also a shortcut. You can do -q. If you enter that thing on the command line, it will store true as a value for this argument. That's hence the action in the back. There's a few other ones. For instance, that you can see the progress indicator value. That's how many rows we've processed. By default, it's 1,000,000, but if you want another default, you can just add -p and give another value. That's an int. And there's another one, two other ones actually. The split value, so after how many rows do you want to start a new file, and the noLF. Actually, the full name would be remove CRLF. If you have text that has a carriage return or a line feed or a combination of these things, CSV doesn't like that, and the import tools don't like them either. So I like to rip them out and replace them. So that's what I'm doing here. All you need to do for the arguments to parse these things, let me get that code for you, is just parse the arguments. And if on the command line you make a mistake or you don't enter all the mandatory arguments, it will just complain. That's as easy as that. And this is how you assign one of the arguments. You can just go args.quiet. That gives you this quiet argument. So you can do things with it. Let's start with the start time, so we know how long it ran. We can show this on the screen. The first thing I want to do is set the output file value. This is one of the things that I like about Python. PowerShell has this as well, but it's these formatting strings. So you can keep the string here clean, and you can put the variables in later. You don't have to close them and then do a plus and an argument and a plus and then quotes and then where am I? You just do the string first with placeholders in them and then you put all the arguments in this nice clean way. I like it. PowerShell has a similar thing. I like this. Now next are two lines that have to do with the logging. And this just makes the logging a standard thing. You get the time and then you get the message. So all I have to do for logging is go log this, and then it will print the time in front of it. You'll see it in a minute. It's a pretty convenient way to do some easy logging. And you can log to a screen or a file. I'm just doing the screen right now. Now let's actually do some logging right away because we're starting this thing. So what you see here, I'm just basically saying, if you didn't put the quiet argument parameter, which I've assigned to a variable right here, so if not quiet, then do logging.info, connecting to database, blah, on SQL Server, blah, and then I put these arguments there. Funny thing, first thing I saw as a PowerShell person, and I bet PowerShell people looking and have never seen Python right now are thinking, where are the brackets? There aren't any. This is how this works. This space means something. As long as I keep indenting, it belongs to this if statement. If I stop indenting, we're done. That was quite scary to me at first, but actually code looks quite clean. If you've gotten used to it, then I like it. It makes your code more readable. All these brackets, I don't know. I've gotten used to them in PowerShell. Got used to the indentation in Python really quickly. So maybe that means something. I don't know. So first thing we need to do is connect to a SQL Server because I'm a SQL Server person, so that's what I'll use. And that's what I run into the most. That's what people hire me for, SQL Server stuff. So I'm getting a IODBC connection. Just connection string, really simple. It's based on trusted connection, so Windows authentication, no username, password, just nope, not doing it. Makes it easier. The next thing we need is we need to get the columns of the table that we want to export because we want that as a header. So I'm doing a metadata query that goes into the SQL Server and gets the metadata. It joins syscolumns with systables and it gets the column names for the table name ordered by the column ID. So you get the columns in the right order. If you do a select star from table, you get the columns in a nice order here. So we can print the header. And then the actual query that will get the select star from table name, again with this formatted string. And then after, let's log that we're starting, getting column names. And here we start the first connection to the SQL Server and we start running. Now for SQL Server people out there that have never seen Python connect to SQL Server, I'm going to type this, not copy paste, just for dramatic effect. Watch me on this one. So what I'm going to do here, I'm going to type the connection. Here we go. Cursor, yes, is connection.cursor. And then cursor.execute. And we're going to do the meta query first. Now don't be scared. For SQL Server people out there, they're going, no, a cursor, no, don't do that. Don't worry, it's not a cursor as we know it. I have run profiler on this thing. It's the first thing I did when I saw the cursor command. I thought, oh no. I ran the profiler, I looked at the query that it runs behind the scenes. It's not a cursor. They call it a cursor here. That's not what it is in SQL Server. This is just a normal result set that is getting. Don't worry about it. So I wanted to stand still with this thing for a bit to show you that. Now, next thing, we want to get the header ready to print. And the funny thing is you could do, let's move this up a bit. You can do header if you wanted to. Header is column 1, column 2, etc. Or you could do a 4-row, we'll see that later, a 4-row in Cursor, do this. But you don't need to write any loops at all, actually. You can write the code that would normally be the loop inside the collection. How cool is this? I'm basically creating a little array, and the code for the loop that fills it is inside it. Just one line of code. This is really powerful and I think also readable. And there's some more stuff that we can do with it later. All we need to do now, since we have the header, we can execute the query. And we can start creating preparing ourselves for the loop that does going through the files. We need a row counter and a file counter. For obvious reasons, we want to start a new file and we want to print how many rows we have, so we need to count them. And now we are ready to create the first actual loop that goes through all the rows in the cursor. And that's just nothing more than 4-row in cursor. Pretty simple. PowerShell people are going to go, yeah, okay. We have that too. So next comes some logic, and I'll just paste all the logic at once that does all the printing. Let's do all of this stuff at once so I can go through. There are some logical things in an application. You can see already here that the indentation stuff is really working well. So as long as I keep here, then this all belongs to the 4-row in cursor. And then there is an if statement here, and all these lines belong to this if statement. So this first one is just some logic to determine, do we already have a file, or did we hit the limit of a file and do we need to start a new file? Or does everything go in one file? We also have that option by just leaving the option away, and it will get a default value of -1. And it will just stick everything in one file. So you don't have to have multiple files. So there's a counter, there's an output file with a nice formatted string again, and all we need to do is call the open file function. So now maybe there are Python people looking in and going, there is no open file function, what are you talking about? It would be easy to put that here, but I just wanted to show people who have never seen Python before, us database people from the SQL Server world, might not have seen this. How you write a function in Python. It's super simple. So I created the open file function, and let me paste that in here. Same thing with PowerShell. It needs to be above in the file where you call it, or in a different file. But you can't put it on the bottom, and then it doesn't work like that. So I need to put it in the start somewhere. So let's define that here. Let's define that here. Very simple thing, just say def, name of the function, and what it has for an input, then a colon, and then you just indent and put all the features, all the code, and then you return whatever you want to return. All I'm doing is opening a file, and I'm giving back a writer. Now this is a pretty cool thing. I'm saying open the file for writing. The new line is just standard, so it will just be a line feed or a carriage return line feed. I think it's a line feed. And then the encoding will be UTF-8. Nice format. And here's the best thing I've found in this library, in the writer. There's a bunch of options, but I love this one. The quoting is quote minimal. Basically, so CSV, right? Comma separated values. But what if you have commas in your values, right? It would be confused. You'd have too many commas. It will go, that's 9 columns instead of 8. It doesn't compute. So text is normally quoted out. There's maybe a double quote around the text. That's pretty standard. So you can have as many commas if you like, as you like. So the delimiter will be quoted out in text columns. But then you have another problem. What if you have quotes in your quoted text? You have to escape those, and there's usually an escape character, and which is often also a quote, so you double quote them, and if you have 2 quotes, you double quote the double quotes, etc., etc. It can be a nightmare. This goes fully automatic, does it perfectly, and the cool trick is only when needed. If there are no if there are no separator values in your text, it doesn't put quotes around them, and it doesn't quote them out, doesn't escape them. There's no need. If you're not using a delimiter in your text, it leaves it alone. Delimiter not there, fine, just don't even quote them out. That's what quote minimal means. I've tested this out with the various importing, bulk insert, polybase, the SSIS, and they seem to understand this. So pretty cool, I like it. Automatic, don't think about it, all good. So that's a function. Python people are looking at this, oh, this is really basic. Yeah, this is for SQL Server people. I'm a student as well. We're gonna get this. We're gonna make this a lot more complicated in the future. Is in the near future. I have so many ideas about this code. So one thing I'm doing besides the standard stuff. So here's the for row, and I open the file, and I'm writing the row, the header. So it's just write row header, and here is the actual row from the file. There is one thing I wanted to show you as well. That is the remove carriage return line feed. Remember that function that was inside that these brackets inside the collection or array? Or I'm assigning a new row here, and I'm doing a same as with the header here, 4 column in row, right? But there is some replace stuff here. Replace the carriage return line feed, and replace the carriage return, and then replace the line feed. If you have a combination of these things, I've seen some pretty ugly files that have a combination of them. Some carriage return line feeds in them, and some have some carriage returns and no line feeds, and some have line feeds on their own. So I'm just replacing all of these things. And only if the type of the column is a string, and else just put the column there. If it's an int, don't bother. That's pretty powerful. And I've tested the speed difference. It's fine, it's fine. Don't worry about this. I'll show you in a bit how that it just works. And I like it. This is pretty simple. Just one line of code to remove all these things. And then when we're done, we can just, this is when we're completely done. So I'm just going, we've exported so many rows. We're done. This is my code. What is this, 75 rows? We're not close to even done yet. This is my start in my Python experience. There is some stuff like for polybase, your lines cannot be wider than a megabyte. All the date columns need to be the same format. I've seen some issues on these exports where the import-export wizard didn't understand the GUID. So I'm going to tinker with this some more. Watch this channel, I guess. And that's it, we're done. So let me quickly prove that it actually works. This is my ddata output. Where I want to put the result. It's empty right now. So let's do a simple example first. I'm going to do Python and then BCP. Powershell people here. I don't have to do /, not needed. And after that I need the server name. Oh, let me show you this. If I don't do anything, it's going to complain because and it's going to tell me what I did wrong. And you can even do --help or if I typed it correctly, --help, and it will explain what all the parameters are and what they're for. So that's pretty cool. Now, let's run an example. I need PyBCP, and I'm gonna do it from the local host. I have a Stack Overflow database, and let's do the post types, just a small table just to show you how it works. And let's do the progress indicator value. I just want a progress per one line, and I want a new file per every 2 lines. Totally ridiculous, of course, but this is just to show you how this thing works. So here we go. Oh, and I forgot something. Let's do the output there as well. That needs to go here, so it's the output. Here we go. So this is only a small table. It's 8 rows, and as you can see, every 2 rows it gave a status, and every 1 row it gave a status, and every 2 rows you got a new file. Just to show you that that works, just to prove that the files are actually there. Post types, there we go, and open them with Notepad. You can see there is one of the files with the 2 rows in them. Now let's just run a bigger file. Let's take the biggest file out there. This is recorded. I can just speed up the recording. Why not? So the biggest file, that would be probably the post history. Let's do post history. Post history. And of course we need to split that on 10 million rows, and I want the progress indicator 1 million rows, which is actually the default. I didn't have to do that, but oh well. Just hit run, and there it is. This is gonna run a while. This is quite a lot of data, so I'm just gonna speed this up a bit. So as you can see, this took quite a bit. This is due to the speed of my computer. I tested this with SSIS, and it takes about the same time, so that doesn't really matter. So that's basically it for my code and my demo for today. But I have a lot of ideas. I want to make this, I want to use this in production, so I want to make it far more usable than it is now. There are, like I mentioned before, I need to make some features in there for polybase handling, for some import-export stuff. I also want to take a look at how I can make it use things, if your database has like change data capture or change tracking, how I can make sure it only grabs your deltas. So you can find my code on GitHub. I'm going to do a whole lot more with it, as I said before, and I'll post all my attempts to turn this into a proper Python package here on this channel. I hope you liked it, and we'll see you next time. Bye.